The Earth is over 4.5 billion years old. Its history is shaped by disaster after disaster.
Asteroid and comet collisions, flares from the sun,
mass extinctions, supernova explosions, cosmic ray bombardment.
You name it, we've experienced it.
Kind of a miracle we're here at all.
These violent events could be why Earth has life.
We tend to think of disaster as a bad thing, but out of chaos can come possibility. When we destroy something, we can also create something new.
Earth has walked the line between survival and destruction.
It's tipping that fine balance of luck between a good disaster and a bad disaster.
Could catastrophe and chaos be the essential ingredients for life? In 2021, scientists investigate something mysterious buried deep inside the Earth. It's a long-hidden clue to our violent past.
Deep down 1,800 miles below the surface of the Earth, our core is surrounded by fluid rock. But inside that, 600 miles high and thousands of miles across, are two denser regions, and they kind of cup the core of our planet like two hands.
One of them is, half the size of Australia, for crying out loud. So, I mean, they're big lumps down there.
There's no reason they should be there. It's a mystery to us.
To solve this mystery, scientists need to examine the rocks buried over 1,000 miles beneath the surface.
We don't really know what these two big rocks are made of sitting there on the core. However, we've been able to sample them. How in the world is that possible? Well, these blobs are actually feeding mantle plumes that are rising up through the mantle.
So volcanoes in Iceland and Samoa, for instance, will dredge up some of these lumps of rock from the mantle. It's a precious chance for us to sample some of that deep rock that we'd normally not get a chance to see.
These rocks are old, very old.
It turns out that the samples in the lava that we think came from these blobs of rock in the mantle are 4.5 billion years old. That is as old as the age of the Earth.
So they tell us something about how the internal structure of our planet was arranged in the earliest days of the formation of our planet. So getting samples from that time is very, very important.
The age of the rocks may be a clue to their origin. They date back to a time of monstrous cosmic mayhem.
Four and a half billion years ago, the solar system was still a pretty wild place. We're approaching the end of the formation of planets. Earth would still be growing.
Back then, you wouldn't necessarily recognize the Earth. In fact, you wouldn't recognize the Earth at all. For example, no moon. The Earth did not have a moon when it first formed.
The young Earth orbits the sun with other infant planets. One of them is an object scientists call Theia. And it's on a collision course with our home.
The Theia collision would have been a spectacular event. It would have been one of the coolest things you could possibly witness in the origin of the solar system, certainly the biggest event in the history of the Earth.
The Theia event is something that completely reshaped the Earth. The planet that the Earth was before the Theia event is gone forever.
The impact melts rock and throws out over 1 billion tons of debris.
During this incredible collision, these two planets were literally broken apart and combined into one big planet. Huge chunks of Theia stayed together as the now molten Earth began to form anew.
Now we can kind of paint a picture of where these big lumps of rock might have come from. They're very old, They're in fact the same age as that large impact event. They could be pieces of Theia.
The giant slabs of Theia sink down into our planet and lie undiscovered for billions of years. Earth reforms from the ruins of both planets.
Now, you might think that a collision like this is just devastating. There's no upside at all. But there are some things that came out of this collision that may have led to the possibility of life.
When these two planets combine, parts of Theia's iron core merge with Earth's.
So that means that Earth collected a much bigger core than it might have possessed on its own. This is good news for us because the core is the source of the magnetic field that protects us.
Liquid metal flowing around in the outer core generates Earth's magnetic field, a protective shield from the sun.
The sun can actually output billions of tons of high-energy protons and electrons in a single burp. That eventually would have stripped away our atmosphere. If it weren't for that active core and that magnetic field, we would look like Mars, just sort of a bare and barren desert.
Thanks to Theia's extra iron, Earth's molten outer core is large. So it cools slowly, staying molten, and keeps on generating a strong magnetic shield.
Because of that collision, the extra iron, the extra heat, we've stayed active. We have a magnetic field. We are protected. And in fact, that's why we're here talking about it.
The catastrophic impact helped life in other ways.
The Theia event was absolutely huge. Not an impact like a 100-mile asteroid making a big crater in the desert, but a planet hitting a planet, causing a huge disk of debris spread out from the Earth, out of which formed the Moon.
After the collision, the Earth tilts on its side and spins incredibly fast. A day only lasts a few hours.
The Earth itself rotates slightly on its side, and if left to its own devices, would in fact experience unpredictable, chaotic wobbling. The fact that the Moon is there stabilizes the Earth, stabilizes our climate.
The Moon's gravitational pull on our oceans creates tides and slows down the Earth's spin, creating a world primed for life.
We actually owe quite a bit to the Moon and Theia, its progenitor, for making Earth a hospitable planet for life.
A giant collision 4.5 billion years ago sounds like a catastrophe, but it was probably the best thing to happen to the Earth. Theia, I would shake your hand because we have a lot to owe you.
We also owe the science of chance because we lucked out with a 1 in a million impact.
If the impact from Theia had been a little bit harder, the Earth may not have recovered as well as it did, and we may not be here to talk about it right now. If it had been a little bit less forceful, then the impact of it may not have made the changes that we think were needed for us to be here now.
We got lucky. Most planets don't get to survive a collision like that and get a bonus moon out of the deal.
Earth's huge collision with Theia was not our planet's first brush with danger. An earlier explosive event could have stopped the solar system from sparking into life and the Earth from forming. Supernovas are one of the universe's most destructive events, releasing in 1 second as much energy as our sun will in its entire lifetime. But rather than wipe us out, supernovas may have kick-started the solar system.
4.6 billion years ago, the solar system's not even really the solar system. It's the precursor of the solar system.
So what we had was a cloud of gas and dust collapsing in on itself. forming the sun in the center, a big flat disk around it out of which all the planets were forming.
There are all kinds of vast clouds of dust and gas floating around the galaxy. What actually causes them to start collapsing and forming new stars? Well, you have to give that cloud a push.
Scientists think this push could be a stellar blast, a supernova.
Supernova are some of the most powerful events in the universe. One explosion can light up brighter than a galaxy. So not only do they eject elements and material, they also eject a lot of light and energy.
A supernova explosion sends a shockwave racing out into space at 18,000 miles per second.
The shock wave from a nearby supernova compresses material together until it begins to collapse under its own gravity.
Was this how our solar system started?
So far, it's been really difficult to find evidence that there was some supernova or point to something that happened that really kick-started the solar system.
The ancient supernova blast faded away a long time ago.
Imagine a crime scene. Now imagine waiting 4.6 billion years after the crime is committed and looking at it and going, there's nothing here, what are we doing? That's kind of what we're trying to do here.
Researchers from the University of Minnesota tried to solve this ancient crime by studying asteroids that fell to Earth as meteorites.
Asteroids are critical for understanding the early solar system, and this is because they have frozen in place all the conditions that existed in that very early solar nebula right at 4.5 billion years ago.
The asteroids contain information about the time leading up to the birth of the Sun and the solar system.
When a massive star ends its life as a supernova, it undergoes what we call nucleogenesis. In fact, we call it explosive nucleogenesis. Literally, the explosion is generating new types of nuclei, new elements, heavier elements. Well, it turns out the types of elements it makes depends on the star that blew up.
The Minnesota team ran computer simulations to investigate which elements form when a star, up to 12 times the mass of the Sun, explodes. Then they compared the results with analysis of elements found in asteroids dating back to the birth of the solar system. They match.
So the remains of the supernova was actually under our noses all along in the elements that have been in our solar system for ages.
And perhaps in the Earth as well.
The Earth has lots of rocks that's made of silicon. That's only produced in supernova explosions. And the very core of our Earth, the thing that keeps us alive, that's iron, nickel. Again, you only get that in supernova explosions.
In February 2021, scientists shed light on the supernova explosions that helped seed our solar system and provide the materials to build our planet. The researchers examined fragments blasted off the giant space rock, Vesta, 4.5 billion years ago, and later landed on Earth. These asteroid fragments contain the fingerprints of not one, but at least 2 supernova explosions.
Our solar system was seeded, was enriched by at least 2 separate supernova explosions. That's incredibly lucky because that is what delivers the ingredients necessary for life.
Scientists believe that these 2 supernovas may have enriched different parts of the infant solar system. One provided the materials that help form the outer gas planets. The other supernova seeded the inner solar system with elements that built the rocky planets, including the Earth. And the scientists think they can even tell the type of supernovas responsible. One was a core collapse supernova, a giant star that likely lived in the same stellar nursery as the Sun. It ran out of fuel and collapsed in a huge explosion. We think that this supernova fed the outer solar system. The other was what we call a Type 1a supernova. It's caused by a small white dwarf star cannibalizing another star.
What we think happens is that a white dwarf has a companion star, which is either another white dwarf or a bigger star like a red giant. And the white dwarf accretes matter from the companion star.
If they accumulate too much mass, they can reach a critical density, forcing them into a runaway supernova event.
The Type 1a supernova explodes with extraordinary force, blasting material across interstellar space, donating elements to the heart of the gas cloud, where the inner rocky planets will form. Once again, our fate came down to pure chance. A series of extraordinarily violent supernova blasts gave the solar system the kickstart it needed and the elements to build the planets, without destroying our future home.
It's a fine line between being too close to a supernova, which will just shred your pre-stellar cloud,
and not too far away that you don't get any of the good stuff. Supernova play both creation stories and destruction stories. They play both roles.
We lucked out. This chapter of the story ends well. The solar system gets the ingredients it needs to build planets. Earth forms in a good location, close to its star. The future looks bright. But then, the biggest bombardment in history smashes into the Earth. From the moment our planet formed, we've been under fire. 2021, a fireball streaks across the night sky in Europe. 2018, a 1,500-ton meteor explodes over the Bering Sea with 10 times the energy of an atomic bomb. 2013, an asteroid explodes over Russia, injuring over 1,000 people.
The Earth is hit by quite a few asteroids every day. You see them as shooting stars, meteors in the sky.
These events are violent and destructive, but these space invaders also brought something every living planet needs: volatiles.
When we say volatiles, what we mean are elements that are really light and easily moved around. Often they're gases, so that's oxygen and water and carbon dioxide and just all those light elements that are really important building blocks for life.
These elements are abundant on our planet today, but were not when it first formed.
From observing other solar systems forming all around us in space, we know that planets as close to their stars as we are to the sun, when they form, they're very hot and dry. There's probably some little bit of water around there, but really not very much.
So what this means is any volatiles will basically be boiled away. If you have a molten surface, anything like water is going to get boiled away.
Young Earth was a dry planet, devoid of all the precious volatiles needed for life. These materials must have been delivered to Earth after its formation. We think volatiles arrived in the early days of the solar system, when the giant planets, including Jupiter, moved around and stirred up the contents of the solar system.
As Jupiter moves, its gravity is pulling on all the objects in there, basically speeding them up. There's a little bit of chaos there in the first place, but now Jupiter is basically supercharging it.
Jupiter's path sends countless asteroids and comets on a collision course with the Earth.
It would have been utterly chaotic. This is a rain of large objects onto all of the inner planets. But these objects that came screaming into Earth were gigantic.
4 billion years ago, a storm of giant asteroids and comets hits the Earth. Some are tens of miles wide. They bring the volatiles that help fill the Earth's oceans and build its atmosphere. But cosmic deliveries can both give and take.
The importance of impacts for atmosphere could go either way. You could have a really big, really powerful impact that blows away the atmosphere of a small fledgling planet. Or you could have a bunch of small impacts of water-rich asteroids that are simply contributing water and volatiles and new chemicals to the surface that might help the atmosphere that's already there.
When you think about an object coming to Earth, is it going to land on Earth? And if it does land, is it going to be an erosive event where material is lost from the Earth, or is it going to be an accretion event where the Earth gains material? Well, the devil's in the details.
Details like the size of the impactor. One study suggests that asteroids between 60 feet and 3,300 feet wide add more to the atmosphere than they take away. And speed at the point of impact also matters.
Asteroids are orbiting the sun, and when they fall towards the sun, they are gaining speed, they're gaining velocity.
Imagine dropping a coin into one of those spiral wells. As the coin gets closer and closer to the middle, it spins up faster and faster.
The closer an asteroid gets to the sun, the stronger the sun's gravitational pull, and the faster the asteroid travels.
So proximity to your star is a vital factor in how intense any impacts will be.
It's possible that the Earth is the right distance from its host star, so that when an impact happens, the energy isn't insanely high, it's just the right amount, that it's the right speed to make everything work.
Supernovas seed the solar system with the elements to build the planets. Asteroids and comets deliver volatile chemicals to the surface of the Earth. Together, they create a habitable environment.
So we need those impacts to happen to have life on Earth.
Disasters created a planet primed for life. But it appears that even more mayhem and chaos are needed to trigger life itself. An asteroid tears through the solar system, hurtling through space at 40,000 miles an hour. Its destination? Earth. Will this space rock inflict unimaginable damage, or will it bring the spark of life?
This idea of a spark of life, we've all kind of seen it in the Frankenstein movies, right? It's alive. This comes from legend, from myth, from history, that there's some sort of a spark that differentiates cold, inanimate matter from living stuff. And in some sense, it's kind of true.
On Earth, we think this spark may have arrived over 4 billion years ago.
The Hadean Eon was the time from the Earth's formation, about 4.6 billion years ago, to about 4 billion years ago. It's named after, literally, Hades. So the conditions on Earth were literally hellish.
It was hot and soupy, a lot of water vapor around, high pressure atmosphere, very intense heat. You wouldn't survive. The planet would literally kill you back then.
It's shocking, and I mean really shocking, that the evidence of first life that we have on Earth dates to the Hadean Eon. This was a terrible place, molten and poisonous and awful. And yet life somehow arose in all of that mess.
June 2020. Japanese scientists simulate the conditions of this hellish planet and then try to recreate the spark of life.
So what the scientists were trying to do was mimic those conditions and see what would happen if you smash a meteorite into the ocean back then. Could it produce sort of the same chemicals that we see life using today?
They use a mix of carbon dioxide, nitrogen, water, and iron to replicate the Hadean environment. Firing a mini meteor at 2,000 miles an hour into this chemical soup triggers a reaction between the basic organic elements, creating amino acids.
We call amino acids the building blocks of life. Really, they're the building blocks of proteins, and life needs proteins to exist. But that's why they're so important. Without amino acids, there's no proteins. Without proteins, no life as we know it.
The experiment proves that meteorite impacts can help build the components for life. But for these building blocks to come together and create life, we need more.
It's like making a cake. You can put together the oil and the flour and the butter and the sugar, but if you don't put it in an oven, you're not going to end up with a cake. You're going to end up with something else.
We thought that the violence of asteroid impacts prevented life from forming. Now, we think they could be an essential ingredient.
If the asteroid impact is big enough and fast enough, it can punch right through the crust. Then you're getting geothermal heat that bubbles up from the mantle. And it is certainly possible to get an asteroid impact that big.
Large meteorite impacts can create hydrothermal vents, which some scientists believe were the cradles of life. They provide warm, wet environments and bring up chemicals from deep inside the Earth's crust. The perfect place for life to begin.
As bad as those conditions seem to us, to the molecules that are beginning to combine and do their thing, that was a wonderful place to be.
It could actually be that the conditions that are best for early life might actually be those just after an impact. So you have sort of this petri dish environment in which life could really thrive.
These vents might be similar to those we see in the oceans today.
These hydrothermal vents provide a little window into what the conditions on the primordial Earth would have been like. And the sort of chemistry that goes on in those hydrothermal fluids seems to be the right kind of chemistry for creating life.
Once again, Earth got lucky. Impacts that could have destroyed everything may have helped spark life into existence.
I once heard this quote from Confucius, that creation is quiet, but destruction is loud. Well, these impacts were both destructive, but they also may have been creators.
Earth leaves behind the Hadean age. The planet calms and life takes hold. But disaster is our constant companion as we prepare to face a storm of deadly cosmic bullets. The universe is a dangerous place for life. There are asteroid impacts, black holes, and exploding stars. But public enemy number one, cosmic rays. Lethal, energetic particles born in violent events. And they come in three kinds.
Solar radiation is basically charged particles coming from the sun.
The second type are galactic cosmic rays, which are fragments of atoms that are hurled out from supernova and accelerated to nearly the speed of light.
And then there's ultra-high energy cosmic rays. We think they come from all the way outside the Milky Way.
Because of all the cosmic rays going through space, the universe is incredibly hostile to life.
Cosmic rays are incredibly small, but travel so fast near the speed of light that they can tear through our DNA and damage it.
You're full of DNA. If that DNA gets broken apart, guess what happens? That could lead to cancer and death.
At first glance, these cosmic rays are the worst things for life. They're terrible.
Despite their frightening rap sheet, cosmic rays may have played a crucial role in the evolution of life. 2020, scientists at New York and Stanford universities investigate biological molecules that have a twin. Mirror image versions called chiral molecules.
The concept of chirality in chemistry is when you have two molecules, two chemicals, that are physically the same. They're made of exactly the same things, but their structure is different. And they're not just different, they're reflections of each other. It's literally called handedness because look, here's my right hand with my thumb over here and my fingers over here. Here's my left hand with my thumb over here and my fingers over here. I can't wear a left glove on my right hand. There's nothing I can do to make these guys the same.
And it turns out this is true not just for hands, but also for a large number of simple organic compounds. Things like amino acids or sugars, which are the building blocks of all life on Earth.
Billions of years ago, early life may have had both left and right-handed DNA and RNA. But life chose to use mostly right-handed molecules. The reason may have been cosmic rays. When cosmic rays hit Earth's atmosphere, they degrade into even smaller subatomic particles called muons. Most muons spin in one direction.
So we have these little muons, which are very energetic, and they're spinning a certain way. And when they hit a molecule, they interact with it. They can disrupt it, they can change it.
Some scientists believe these spinning muons interact more readily with right-handed DNA and RNA, triggering mutations.
Some mutations are beneficial, but they have to get a chance. So if you have right-handed molecules and left-handed molecules, and they're both being hit by muons, the one that's hit more gets more chances to have a beneficial mutation.
Cosmic rays may have given right-handed life an evolutionary advantage. Left-handed life could not compete.
It's like throwing dice. If you're trying to get double sixes, and the left hand only gets to throw 10 times, and the right hand gets to throw 100 times, more likely to get double sixes with the right hand than the left hand.
But the dice don't always land in our favor. 359 million years ago, Earth's luck ran out. And cosmic rays may have lived up to their reputation as the baddest particle on the block.
Earth's oceans were teeming with marine life. And by this period as well, plants had started to colonize onto the continents and land masses, attracting animal life, insects, millipedes. And it's in this environment that Earth experienced one of the greatest mass extinctions in the history of life.
Something killed off 97% of all vertebrate species. We call this wipeout the End-Devonian extinction. One possible explanation, a supernova. When some dying stars explode, they fire out cosmic rays.
This radiation bombards the upper atmosphere of the Earth, and drives the chemistry of nitrogen turning into nitrogen dioxide, a gas which itself then reacts with the ozone layer and destroys it.
Without the protective ozone layer, ultraviolet radiation from the sun bombards Earth. Radiation rains down for thousands of years, damaging the DNA of plants and animals. Many species die out.
The Endovonian mass extinction mostly affected marine life. This is where we see the greatest percentage of deaths.
The oceans, once populated by fish the size of school buses, now host fish no bigger than a sardine. These smaller fish reproduce quickly. In the challenging environment, they adapt and diversify faster than larger species.
Mass extinctions not only wipe the slate clean and provide other animals and other life forms an opportunity, it creates a sort of chaotic and complex environment that drives natural selection and evolution.
If a supernova was to blame for this extinction event, scientists believe that the culprit was 65 light years away. Any closer, and Earth's luck would have run out completely.
It seems the existence of life is always balanced on a knife edge. One exploding star goes off a little bit too close to us, and we are all destroyed. So there's this wonderful balance between just violent enough and too violent, and we have been lucky enough to dance on that edge for 4.5 billion years.
This mass extinction reset life on Earth and paved the way for four-legged creatures, our distant ancestors. Cataclysmic events go hand in hand with human evolution. Some knocked us back, and others, like the event 66 million years ago, gave us a push forward. 66 million years ago, a massive asteroid crashes into the Earth. It triggers a huge extinction event. Without it, humans may have never evolved.
At this time in Earth's history, we had these enormous plants and gigantic insects that actually would be incredibly terrifying if we saw them today.
Pterosaurs sail through the air. Huge marine reptiles dominate the oceans. And the T-Rex is the king of the world.
Then, a glowing object appears in the sky.
I'm sitting on the beach, what was then going to be the Yucatan of Mexico, enjoying a drink with a little umbrella. But up there in the sky, all of a sudden, approaching me at 40,000 miles an hour, is Mount Everest, glowing thousands of times more intensely than the sun. And it's just seconds away from dropping on my head.
A 6-mile-wide asteroid slams into the Earth. The impact throws trillions of tons of rock and dust into the air. The rocks heat up as they fall back to Earth, setting the planet on fire.
That beach holiday suddenly turns into absolute nightmare.
The impact also throws up soot, choking the atmosphere.
Now the skies are blotted out by all these materials, so the sun is no longer shining brightly on the surface.
Plants need sunlight to photosynthesize. Without this vital energy source, many species die out. With their food source gone, plant-eating dinosaurs starve to death, followed by their predators.
It was a huge disruption to all of life on Earth.
The dinosaurs have been around for 160 million years at this point. That's no small amount of time, and in one event, they're gone.
Again, the dice roll is in our favor. Most dinosaurs become extinct, paving the way for the evolution of mammals, leading, eventually, to humans. Without the asteroid impact, we wouldn't be here.
As a furry primate on this planet, I kind of like the KPG impact, right? I'm here because of it. We all are.
Some plants benefited from the asteroid strike. To learn how plants changed after the impact, Smithsonian scientists examined thousands of tropical plant fossils from the time of the die-off.
This disaster opened the way for new types of plants to develop.
It transformed the plant kingdom, producing a richer and more diverse global ecosystem.
Before the asteroid strike, conifers and ferns dominated the tropical forests of South America. But afterwards, falling ash from the impact enriched the soil, and fast-growing, flowering plants took over.
The impact was very hard to recover from, but it actually opened the opportunity for a greater diversity of plant life, which ultimately has benefited us as humans because it has allowed us to have more food sources.
This new world order eventually gave rise to the modern Amazon rainforest, home to 10% of all species on Earth.
It really destroyed and remade our entire environment. The world grew back, of course it did, here we are, but it changed everything.
And another age, maybe, just around the corner.
We should absolutely expect that at some point in the future, and I'm not saying you should lose sleep over it, but at some point there will be another mass extinction. Maybe that will be the end of our days. The intriguing question is, what might come after humans on planet Earth?
Catastrophe may be the universe's recipe for life throughout the cosmos, one that every planet must follow.
Looking at our own history, life thrives on catastrophes. We need these disasters for evolution to work. So hopefully, and I hate saying this, I know how it sounds, hopefully these other planets have had terrible disasters as well.
Think about the word disaster. It means bad star. It means that something has gone wrong, something that's dangerous. We are children of disasters. There's no way you get us without planets colliding, without asteroids and comets streaming through the atmosphere, without even stars exploding in supernovas. You are a child of that violence. That's part of the environment that we grew up in a cosmic way. And I think that is tremendously beautiful.